value. Okay, so really quickly. Okay, so let's get started here. So pass by reference versus pass by value is a concept that's kind of like it's very similar to a lot we were talking about with underlying things that exist in JavaScript, whether or not you choose to use it. So what that means is it's something that even if with array methods, I guess the thinking there is, well, if you really don't want to use an array method, you could get away with never using it. But with pass by reference and pass by value, it's something that's always going to exist in JavaScript, whether or not you choose to use it. And so it really benefits you to understand as well as possible because there's really no way to avoid it. The core kind of idea behind pass by value versus pass by reference goes back to what we talked about during our first week, actually, around the difference between primitive and complex or non-primitive data types. So we're going to do a quick primer on that, and then we're going to dive into some more like specialized cases of. I think so far, a lot of times when we write code, we just assume that something looks right and that it should work. But as we'll see today, a lot of times when we make those assumptions, it also works against us because there are a lot of times in which we're actually not quite clear what's happening behind the scenes. And if we slow down and actually try to follow it step by step, there may be some logical inconsistencies, or at least inconsistencies based on what we've known or what we've seen so far. So the goal for today is to really give you a great sense of kind of what the definitive differences are between primitive and complex data types and how to use them in JavaScript going forward. Okay, so on that note, let's get started. So primitives in JavaScript hasn't changed. They're the same as what they were with the last time we covered this, right? So the primitives are still numbers, strings, booleans, undefined nulls, and symbols. And the complex values are still objects, which includes objects, both objects and arrays, and also functions. What all of this means is just that primitives are things that once you create it, you cannot change. If I create a string, I can never change that string ever. The only thing I can do is create a brand new string that could probably take some properties or take some features of the old string, and I can incorporate the changes into it. But I can never fundamentally change the original string, right? Same thing with a number. I can take a variable and I can assign a number value to it. I can assign a new value to that variable, but I can never change the underlying number, right? 4 will always be 4. It can never be 5 or 6. I can't add 1 to 4. Historically speaking, when I have added something new to a number, all that means is that I've now basically returned back to you a brand new number that takes into account how much I've increased it or decreased it by. Sorry, did you have a question? Okay, cool. Sorry. So primitives, once again, just means they are things that once we create, we cannot change. Complex objects, such as objects and arrays, however, and also functions, are things that we are able to change, right? And we do it quite often. If you remember in our section on arrays, I could easily create an array with 4 things and say, hey, I want to add another thing to my array. I could use .push or .shift, and all that would do, or sorry, .push or .unshift, and all that would do is that would actually add another item to my array. So I have an array of 4 things. I can really easily take away an item, add in an item, do something else to it, etc. But the short message there is, after I create something, that thing is not set in stone, right? I am able to go back and edit it and change what it is fundamentally. And that's because they are things that JavaScript allows us to change, which is why we put them in a different bucket than we do the primitive values. So let's take a look at. So here's kind of where we'll talk a little bit more about like things that maybe we've intentionally almost glossed over up to this point in this course, but now we're going to take a little bit more seriously in terms of actually understanding the details of what's happening. So on line 2 and line 3, I have 2 variables. One's called British city, which is equal to the string called York, and the other one's a variable called American city, which we set it equal to the variable British city. Now on line 5, I'm redefining the American city variable. I'm setting it equal to the string new plus the old American city variable, or the value that was associated with the old American city variable. And now when I console log out British city, and also when I console log out American city, you'll notice 2 things. One, if I take a look at American city first, That's what's being printed on the second row. It kind of makes sense, right? New York. On line 5, I'm clearly adding the string new to the string York, which is what the old value of American City was, and I'm basically joining those two strings together, and I'm assigning it to the variable American City. So when I print that out, you'll notice I do print out New York. However, if I look at the old variable British City, you'll notice how it's actually still York. Even though so on line 2 I've defined it as equal to the string York, and even though on line 3 I've set American City equal to British City. Sorry, I'm having trouble pronouncing today. Even though I've set American City equal to British City, at no point did I ever change the value of British City, right? I've never reassigned the variable, and I've actually never changed that variable at all. And that's why through all of this, even though I've actually changed the value of American City several times, I never changed British City, and therefore the value of British City is still York. Okay, so that's kind of the first thing that's to kind of highlight here. Even though on line 2 I set the British City variable equal to York, on line 3 I assign American City to British City. Even though I'm changing American City, you'll notice how that change didn't transfer over to British City. And so let's take a look at the next slide as to why that would be. If I compare that to something like this example here, where in my initial variable for British City, now rather than setting it equal to a string, I'm now setting it equal to an array. The array has one element, which is the string York there on line 2. On line 3, I'm now saying, hey, let American City equal to British City. And on line 5, I'm saying, now let's unshift the string new onto American City. Remember, unshift just means add a variable or add a value to the beginning of the array. So in this case, all we're doing is adding the string new to the beginning of the American City array. Now when I console log out British City and when I console log out American City, notice how they're in sync. In this case, both of them are now printing new and York. And so the big question now is, why does it behave this way? And so this is fundamentally what we're going to talk about in today's class. We're discussing the differences between pass by value versus pass by reference. What value means is value is the underlying value of a particular variable. And so when we pass something by value, what we're actually saying is, hey, let's actually take the fundamental underlying value, something that we know that cannot be changed, which in this case applies to our primitive value, and let's pass a copy of that value. Okay, so if we go back to the previous slide here, when we define British City as equal to York and American City is equal to British City, what we're really saying is, well, we know the string York cannot be changed. It's permanent, right? We can never change that string. So when we set American City equal to British City, what we're actually doing is we're not actually saying, hey, we'll have both of these variables point to the same instance of York. What we're doing is we're actually copying York, making another copy of it, in this case another string called York, and setting that equal to American City, or setting American City equal to that value. And so when we deal with primitive values, what we say is we exercise pass by value, which means if I was ever to assign a value to something that's a primitive, I'm always creating a copy of that value and assigning whatever variable I'm looking at to that copy, not the original value. That's in contrast to what we did here for this array with the value York in it. What this is saying is, hey, British City is initially an array. An array is a complex value, right? Which means that we are able to change this array on an ongoing basis. And therefore, when I set something equal to this array, I actually have to make sure that it is that instance of that particular array, because that array can change over time. And if I set American City equal to British City and I change the underlying array in British City, then that, if I'm setting it to the same exact instance of the array, then whatever I do to the array will be reflected in both British City and American City, which is what we see here, right? In this case, on line 5, I add the string new to the beginning of the array, and that's reflected when I look at both British City and American City. If I was looking at this, if I was doing a pass by value instead, and which basically means I create a copy of the British city array and assign it to American city, then that basically means whatever I do to American city will not be reflected, will not change the underlying array associated with British city. But because British city is something that is changeable, and I want to set this reference relationship equal to it, we have to remain that consistency. It's a little bit hard to explain verbally, but in the next couple of slides, we'll have a few arrows and diagrams to hopefully clear it up. I just want to kind of draw your attention to this kind of phenomenon is the entirety of today's class, right? It's just why is it that when we do when we refer to primitive data types, why we copy the value, and when we refer to complex data types, why we actually do what we call a reference, right? A reference basically means the original value. Like we make a reference to that instance of the original value. Okay. So here, let's take a look at kind of what's happening on a step-by-step basis, right? So on line 4, we create this variable called first, and we set it equal to the number 20. Just to recap, and hopefully this time this is reviewed by now, numbers are primitive data types, which means once you create a number, we are not able to change that number. You'll see we're able to change first, but we're not able to change the number, right? So that's why after we create this variable called, once we create the variable called first, there's a, there we go, okay. So once we create the variable called first, there's an arrow, right, that ties that variable called first to the value 20, which you see in the bottom right-hand corner of your screen, okay? On the next line, if I reset the value of first equal to 30, notice how a few things happen here, right? One is I'm not changing the 20 to 30. What I'm doing is I'm pulling out a new value of 30, and I'm drawing the arrow from the variable first to the new value of 30. Okay, this is once again what we mean when we say primitive. We're not changing the 20 into 30. We have a value of 20, and then we have another value of 30. And all we're doing is we're telling the variable first, say, hey, don't point to 20 anymore. Now point to 30. And that's why the arrow on the bottom right-hand corner of your screen, we didn't show the old value, but essentially what we're doing now is we're pointing that variable to a new value of 30. On the other hand, on line 7, if I create a new variable called second, and I set it equal to the value of 30, notice how on the right-hand corner of your screen again, notice how we're actually not pointing the second variable to the 30 that the first variable is pointing to. We're actually pointing the second variable to its own copy of the number 30. And if we was ever to change the second variable, if I was to say, hey, add 1 to 31 or add 1 to 30 and have that be our new value, what I've done now is I've actually changed the value that I've now changed whatever value the second variable is pointing to, but I never touched the first. And this is why we do pass by value, is because we want to make sure that there always exists this distinction for primitive data types, this distinction between these different variables. And with the big takeaway here for you will be that whenever we're dealing with primitive data types, there's always only one variable pointing to one value. Okay, we can have multiple copies of the same value, but they will always each have only one variable pointing to it. Okay, console log out first, console log out second, I get 30 and 31. This, however, is in contrast, we're going to do one more slide on this too. Similarly, if I was to keep going on with the primitive values, on line 1 here, I go and once again create a variable called first, and I set it equal to the value of 20. On line 2, I create a variable called second, and I set it equal to the variable of first. Once again, when JavaScript sees line 2, the first thing it says is, okay, well, let's figure out what's on the right-hand side of the equal sign, right? The right-hand side of the equal sign is this variable called first. And what is the value of first? The value of first is 20, which is a primitive. So therefore, when I set second equal to 20, I cannot have more than one variable pointing to the same primitive value. So the only way for me to make this relationship work in line 2 is for me to make a copy of the value of first, which on the bottom right-hand corner of your screen, you'll see we made a copy of the value 20, and then we pointed the second variable to that copy of 20. So first is pointing to its own copy of 20, and second is pointing to its own copy of 20. And so if I was to change the variable second in terms of setting it equal to a new value, because the arrows never touch, or rather because the arrows never intersect or converge, whatever I do to the variable second and its value has no bearings on the value of first and its value. So far so good? This is just for primitive so far. Okay, so let's contrast this now to what we do when we take a look at complex values. On line 7, I've now created this. This array, right? First is equal to this array with two numbers in it, 10, 20. On the bottom right-hand corner of your screen, ignore that middle reference column for now. I'll bring it back in a few minutes. But for now, let's just assume that the variable first is pointing to this thing that points to this array of 10, 20. If I do first.push30, I'm basically changing the underlying array, right? In this case, I am changing the underlying value, and I'm adding 30 into it. Remember how in the previous example, when we were talking primitives, whenever we added, let's say, 1 to a number, we didn't change that number, right? We basically created a brand new number and pointed the variable to that brand new number. When I added 1 to 30, I didn't change a 30 to a 31. I created a new number called 31, and I pointed the old variable to that new value of 31. Here, the point in the middle column, the point of that reference, you can think of a reference as just an address. It's where in the computer's hard drive or RAM, wherever in the computer's memory, we're currently storing that array. The reason why we have the memory variable there is just to show you that here on line 8, when we add the number 30 to the first array, we're not creating a brand new array that has 30 onto it, right? And pointing the old variable to it. We're actually just changing the underlying array and just shoving 30 into the very last slot. So that's why, so the point of this is show you that that reference, that address, that memory, it doesn't change. One thing to just kind of caveat here is when we talk about memory, for arrays at least, usually when we say the memory of an array, it's the address of the array, it refers to wherever the first element in the array is, right? So when we say the reference doesn't change, it just means that we do not change where the array starts, right? That 10, that's being held in the same place. All we're doing now is adding subsequent values to it. If, on the other hand, this was numbers, it'd be a completely different story, right? If it was numbers and our first variable was being stored at a certain memory for 20, when I add 1 to 20, I'm creating a brand new number, 21. That 21 is being stored in a completely different place than where that 20 is stored. And so when I change a primitive, so to speak, my reference or my address is going to change. Here, my reference or my address does not change because I'm changing the underlying array. So when I console log out this variable, I get the changes here, or I get, just kind of following the arrow here, I go back to the address I was previously looking at, except now the value that's tied to has 30 included in the very end of it. If I was to go back to the example I saw earlier, right? Whereas this one, I think, makes a lot more intuitive sense. On line 1, I create a variable called first. On line 2, I create a variable called second. In both cases, the values are the exact same. And I guess the example here is that, like, if I have, a Toyota Camry and my friend buys a Toyota Camry, even though we both have Toyota Camrys, we don't have the same car, right? They're two different cars. Whatever I do to one will not affect the other. And so in this case, even though the values are the same, notice how they're in the middle reference column. Notice how those exist at different references or different addresses. That basically means they are distinct versions from each other. And once again, what we do to one does not affect the other, even though the values are technically the same, right? It's just having two different copies of the same thing. Okay, now here's where actually this part also is just to reinforce the idea that whatever we do to one of the variables will not impact the other, right? Because notice how when I add 30 to the second array, the address for first doesn't change. The value for first doesn't change. The address for second does not change, and the only thing that changes now is the value for the second array. And then the last example we'll look at here is basically what happens in parallel to what we talked about with primitives. We create a variable called first, and we set it equal to this array 10, 20. But now we say, hey, let second equal to first. So remember how with the primitive will say, let's figure out what's on the right-hand side of line 3 first, right-hand side of the equal sign. Oh, it's first. What is first? First is a number. A number is a primitive, so let me make a copy of that number, right, and point second to it. In this case, because first is not a primitive, it's a complex value, the way the JavaScript will look at it and say, once again, is let me resolve the right-hand side of the equal sign on line 3 first. Oh, great, I'm looking at first. What is first? First is an array. It's a complex data type. And so what that means is, hey, let me draw an arrow from second to that same exact value. Okay? The arrows on the bottom right-hand corner, I think they're somewhat misplaced. The goal here is to show you that, hey, basically when I trace the value of second, it actually is not being pointed to a copy of first. It is pointing to the same exact array as first. And so therefore, when I say second.push 30, I'm changing the value of the second array, right? And changing the value in this case just means, hey, I'm adding a 30 to the end of it. But that change is also being reflected. If I was to back up the arrows, that because I have two different variables pointing to the same array, when I change the array through one of the variables, that change is also going to be reflected through the other variable as well, right? It's like me and my friend are like holding two ends of a rope. If one of us, shakes the rope, the other person is going to feel the impact for it too, right? Or maybe think of it another way. What's a good analogy here, right? It's like we're both driving a car with two steering wheels that both control the car. If one of us turns left, well, the car is going to turn left for the other person as well, right? Because we're fundamentally looking at the same exact thing. Here, the point once again is to show you that with primitives, we make a copy and we set the variable equal to the copy of the value. For complex values, what we're doing is we're actually setting both variables equal to the same instance or the same value. And therefore, whatever I do to that value through one of the variables is going to be reflected through the second variable. And all of this is made possible based on the fact that I am able to change the value of an array or an object or a function because they're complex. I cannot change the value of a number or a string or a boolean. And therefore, JavaScript says, because you can never change the value, it's safe to make a copy of it. Because you are able to change the value of a complex data type, let's make sure that you're always referring to the same version of it in case one person or one side makes changes that the other side also wants to capture. Any questions? Okay. Yep. Sorry, the question? Yep.
Dot slice creates a new copy, right?
Yep, exactly.
So it's a different reference value.
Yep, exactly. So you shadowed the next slide very nicely, right? This is why when we do arrays, why getting a new copy of the array is a lot of times really valuable, is because we want to create a scenario in which we have our own copy of an array that we want to play around and do things with, and we intentionally do not want it to affect everyone else who's also using the array. So therefore, we make our new copy of there. So in this case, first has an address. It's equal value to 10, 20. When I do second equals first dot slice, I'm creating a new variable that's pointing to a new address that's pointing to a distinct separate copy of the value. And so now whatever I do to second, once again, will have no impact on first because it is a distinct copy of it. Cool. And so where does this kind of come into usage, right? Like we've kind of talked some basics of saying, hey, if A equals 5 and B equals A, then how does that transitive property or how does that transitional relationship work? And that's the fundamental parts of it. In terms of where you see this more in real life, you actually see a lot when we talk about passing in inputs into a function. Okay, So here in this example, on line 1, I've created a variable called mynum, and I give it the number 10. On line 3, I create this function called adds20, and I'm passing in a number. And I'm basically adding 20 to the number, and I'm returning the number. Now, on line 8, when I actually call adds20 and I pass in mynum, here I am actually passing in the value of mynum into the adds20 function, right? The question becomes, what am I passing in? Am I passing in a reference or the exact instance of mynum? Or am I passing in a copy of mynum, right? A copy of the value of mynum? And the short answer to that is because let's take a look at what mynum is. Is mynum a primitive or a complex? In this case, mynum is 10, which is a number, which is a primitive. Therefore, what that means is I'm passing in a copy of 10. I'm not passing in the actual instance of mynum. And so therefore, when I pass in 10 into adds20, num there on line 3 becomes 10. On line 4, I'm adding 20 to 10, so num is now 30, and I return num, which I then capture as a variable return num on line 8. When I console log out my num on line 10, notice how my num is still 10, right? Because what got passed into the adds20 function was not that instance of my num. It was a copy of 10. It was a copy of the value of my num because my num was a primitive. And so therefore, when I look at my num, it didn't change. It was 10 and it will always be 10. When I look at line 11 to see what the output of the function was, I get back 30. And that's purely because of the fact that on line 8 there, when I pass in my num into the adds20 function, I'm not passing in that reference or that address or that instance of the variable. What I'm passing in is a copy of the value of that variable. So therefore, because of the primitive, I'm passing by value. Okay. The flip side of this will be then if I change all of this to arrays, right? So in this case, the function, the layout is almost identical, except now what I'm doing is my initial variable is a variable called my array. It's an array. I have a function called pushes20, and all I do is add 20 to the end of the array, and I return the array. This logically looks almost identical to the previous page, except now on line 8, when I pass in my array, JavaScript is going to say, okay, what is my array? Is my array a primitive or a complex data type? And the answer is it's an array, which is a complex data type. And so what gets passed into pushes20 is the actual variable my array. It is that instance of my array. And so on line 4, so basically what that means is inside the function, the variable array there on line 3, the input, that is equal to my array, right? It is that array variable is the exact same as the my array variable. Both are pointing to the same address, which is pointing to the same value. Therefore, on line 4, when I push 20 onto the end of array there on line 4, that is the exact same as me pushing 20 onto the end of my array, right? Because once again, my array and array are both looking at are pointing to the same exact array. So when an array changes the underlying value, then that underlying value is also changed for my array as well. And that's why on line 10 and 11, when I console log out my array as well as the array that gets returned, I get back the same exact value, which is 10, 20. And once again, that is purely because my array was a complex data type. So whenever I pass my array into any function, I am actually passing in that instance of the variable, right? It's not a copy of my array. It's not my array.slice. It is that actual instance of the array. And so anything I do to that array within the pushes20 function is also going to be reflected outside of that pushes20 function, because the array variable on line 3, it's pointing to the same exact thing that the my array variable is pointing to on line 1. So if you're having some trouble kind of still understanding this during the workshop, feel free to reference back to these 2 slides. I think they kind of capture the heart of what we've been talking about today. But just know that whenever you're dealing with primitives, you're always passing in a copy of the value, not the original value. With a complex, it's the opposite. You are always passing in the original value. You're passing in the original, not a copy of the value. So this just kind of brings us back full circle to, I think last week we talked about why we use double equal signs versus triple equal signs. And I said it was because double equal signs checks to see if we were comparing the same data type, it would try and coerce it to the same data type first. What triple equal sign basically does is it actually checks it by reference, not by value. And so what that means is if I look at line 3 and line 4 here, right? Line 3 and line 4 are two different variables, but they have the same exact value of an array of 1, 2, 3. But remember how if I was to draw the arrows for this, array 1 will be pointing to one value of the array of 1, 2, 3, and array 2 will be pointing to a distinct copy of 1, 2, 3. If I was to do does array 1 equal array 2, I get back false. And the reason why for this is because in JavaScript, when you use triple equal signs for complex data types, what it will do is it will try to figure out, are they comparing not by value, but by reference? As in, are they pointing to the same address in memory? So if I have something like this, array 1 equals 1, 2, 3, and array 2 equals array 1, because array 2 and array 1 are now two variables that point to the same reference, that point to the same value, if I was console log out array 1 equals array 2, I would get back true. And so this is something you just need to be aware of when we're talking about how to compare equality between complex data types. And in fact, one of your problems today in the workshops will be kind of building your own function that will allow you to actually evaluate equality between complex data types. Or basically, how, in the previous example here, you'll be writing a function that tries to figure out how do I do a function that actually checks the value to see if these two are equal. So this is just kind of one warning for you to know that one limitation of the triple equal sign is that when it comes to complex data types, it will always compare the values based on the reference, not by the actual value itself. Yep. And then the last thing we'll talk about here is a distinction that it's kind of nice to know. It's not fundamental because, in general, you probably won't come across it nearly as often. It's this difference between the idea of a shallow slice between a shallow copy and a deep copy. Looking at the example on this page here, right? Array 1 is equal to an array of 1, comma, and then another element, which is an array of 2, 3. And the problem now is when I do array 1.slice, what it'll do is it will make me a copy of the values of array 1. If I console log out array 2 and I set it equal to each other, I get back false, which so far makes sense, right? Because the idea is, well, a slice creates two different copies, so of course they're no longer equal. They're pointing to different references. However, if I go back to my previous example, I have my array 1 and array 2, which is a copy of array 1. If I go into array 1 and I go to the second element, that array of 2, 3, and I push in 4 into it, and I console log out array 2, 1 and array 1, 1, you'll notice how what's happening here is on line 11, you'll see that even though I changed the second element of array 1 by pushing 4 onto the end, that change was also reflected onto the second element of array 2. You might be asking, well, we made a slice, right? Aren't these two copies supposed to be completely distinct now? Like they should have no ties with each other. And the answer is yes, but not in every case. So this gets to the idea of what a shallow copy is versus a deep copy. Well, a shallow copy, which is what slice is, all it does is it goes through one level and just says, hey, for every single value in this array, if it's a value, I'm going to copy it based on the value. If it's a complex, I'm going to make a reference to it. So basically, it only makes a copy of something at one level deep, right? So when we make a shallow copy of array 1 here, it will go through and say, great, let's make our own array here. First element, what is it? It's a number, it's a 1. Okay, great, let's make our own copy of the value of 1. Let's move on to the next one. What's the second element? Oh, it's an array. Well, in that case, then let's just keep a reference to this array in our new copy. And so on line 13 there, when we console log out the second element of array 1 to the second element of array 2, notice how the triple equal gives us true, which means they're actually still referring to the same exact value, right? So this is what we call a shallow copy, which is when we make a copy, we only go one level deep. This is in contrast to a deep copy, which as the name implies, basically says, we will go through, let's say in this case an array, and for every single element, we will go into it and we will iteratively go through and make a copy of of everything in it until we get to only primitive data types. And so later in this in this workshop, or the one or two workshops from now, we'll go through an example of how to make a deep copy function. But for now, just know that this is the difference between shallow copy and deep copy. Know that slice only makes a shallow copy, and so even though slice does in general make a copy of an array, it may not work universally in all cases. And the cases in which it wouldn't work would be if the elements of the array are complex data types themselves, right? So if you have an array inside of an array. And that's pretty much it for pass by reference and pass by value. Okay.
Why does triple equals work for primitives?
Triple equals works for primitives essentially because the idea is with a primitive, it's impossible to have two different values have the same value and not be the same thing. Like if I have, let's say, if I'm comparing, let's say 4 to 4, there's no way that one of those could ever not be a 4. Whereas if I was comparing an array to an array, the idea is that like there's a chance in which one of those arrays could have been changed or will be changed. For now, just like the most important thing to just take away from triple equals is just know that for complexes, it is only looking at references, not at values. And so if you expect it to do that, it will give you back the wrong answer. Okay. Any other questions? Just as a heads up, this workshop is probably one of the harder ones. So definitely take your time. Feel free to review the slides. Me and the fellow will be here for help to help out in case if any more questions. But otherwise, I will let you get started. All right, let me stop the share really quick. And then I know your workshops isn't open yet. I'm going to open up in like 30 seconds. Okay, so feel free to go to your rooms and I will open up your workshops right now.